Hello students, I'm Dr. Gajendra Purohit. Welcome to our YouTube channel where I upload videos for engineering, mathematics and BSc students. Today I am going to teach you about recurrence relation. Plus, how do we solve the difference equation that is formed from this? How do we find its CA for PI? I am going to discuss all of this. Let's start. Let a n be a sequence and an equation connecting a n with the finite number of other terms like a n minus 1, a n minus 2, a n minus k. So if we have a term and the term has a relation with another term here, then such type of relation is known as a recurrence relation. Did you get it? Okay. For example, like I am trying to tell you that, let's say we have here the nth term. So the term before n is what we have, right? So I want to tell you that if by chance we have any sequence, let's say we have a sequence a1, a2, whose term will be this an minus 1, an, and then this is coming an plus 1. So we have terms for any of these, right? So any of the term, like let's say this an plus is one term, then this is written as a relation to the previous term. Is it right? Now moving further. If say it means its value is related to its previous terms in relation. For example, I want to say that suppose an plus 1 is equal to an plus 2, an minus 1. What will we have here? It will be a recurrence relation. It is important to note that for any sequence, any term's value is determined by its relationship with its previous term. This relationship is known as a recurrence relation. Is it clear? I will give you an example, the Fibonacci sequence, and this sequence is such that the next term in it is related to the previous term, like suppose we have 1. The sequence starts with 1. Each subsequent number is found by adding the two numbers before it, 1, 1, 2, 3, 5, 8, and so on. What's the relation? An is equal to an minus 1 plus an minus 2. This is a recurrence relation, meaning that this type of relation that we have is a recurrence relation. When studying special functions like the Bessel and Legendre functions, we often encounter recurrence relations that resemble this type of pattern. Now I would like to tell you that the equation which is formed from the recurrence relation that we have, what is it called? So it is called a difference equation. What we have here is a difference equation, right? Now this difference equation is not exactly the type of a differential equation, but yes, we can solve it in a similar way. Okay. We will talk about the order of recurrence relation. What is the order of that recurrence relation? So the order of recurrence relation is the difference between the greatest suffix and least suffix. So whatever suffix we have, as I am explaining to you, we observe a recurrence relation. What would be its order? Now its suffix is n. This is the largest suffix and this is the smallest suffix. What will be the difference between them? If we take the difference between these two, as I have shown you earlier, then what will we get? We get 2. So that's the order of the recurrence relation. So this is how we get the order. Let's move on. Let's discuss linear recurrence relations, similar to linear differential equations. It includes y, dy upon dx and d2y upon dx square. They should have a degree of 1, meaning it should not exceed 1 and should not involve multiplication. In the context of linear recurrence relation, the terms of the sequence should not include squared on cubed terms, nor should they involve products of the two terms, right? Moving further. If we have such a recurrence relation, then that will be linear for us. If it is in the product or square term, then it becomes non-linear recurrence relation. What will we have here? So we will have a linear recurrence relation. What does a linear recurrence relation with constant coefficients mean? It means that coefficients of a recurrence relation, what should they be? So they should be constant, isn't it? So such recurrence relation is known as a constant coefficient recurrence relation, right? Yes, and we can write it in this way. Now today we will talk about the linear recurrence relations with constant coefficient and how do we solve them. This is similar to solving differential equations with constant coefficient. Here we will find CF and PI. It means that whatever recurrence relation we have, I will demonstrate further. Let's assume we are given the recurrence relation an plus 3, an minus 1 plus 2, an minus 2 here, which is equal to 0. So how do we solve this? The answer to this part will be CF and the answer to this part will be PI. Is this clear? If instead of 0, let's say we are given an square plus an plus 1 as I am explaining to you. So the answer for this part, what will we get? It will be PI. And what will be the final answer? It will be CF plus PI. Now let me explain the concept of CF to you first. So now if we have 0 here, then how do we solve this recurrence relation? Because we have a constant coefficient recurrence relation. First, we will calculate its auxiliary equation. Then, we will calculate its roots. If all of its roots are real and distinct, this is how we express it in terms of its CF. Let me illustrate this with an example. Here, we have been given a recurrence relation. Can you see it? How do we solve it? Let me explain the method to you. Now, moving ahead. Put x power n for an here. And if we calculate its auxiliary equation, then it will be xn, then 3xn minus 1. Plus 2xn minus 2 will be equal to 0. What will we do here? We will take out the common x power n minus 2. We will get it as x square plus 3x plus 2 is equal to 0. So, in this way, it went to 0. Equate this to 0. So, x square plus 3x plus 2 is equal to 0. So, the value of x will be minus 1 and minus 2. Both of these values are distinct and real. So, we will write the CF we have like this. Then, we will get yn is equal to a1. What will be there? This will be minus 1 power n plus a 2. This will be minus 2 power n. So, this is how we solve it. Now, let's discuss what happens if the roots given here are equal. What will happen and how will we solve it? So, suppose I take a recurrence relation. And the relation is an plus 4an minus 1 plus 4an minus 2. Let's say we have a recurrence relation here and I am going to solve it now. Pay attention. I want to explain that we will denote an as xn directly. So, this expression here simplifies as x square plus 4x plus 4, or we can denote it as m. Okay, m square plus 4m plus 4 will be equal to 0. Now we will solve this. We know the value of x, what will it be? Minus 2 and minus 2, both are repeating, and whenever it repeats, and then students, we have n here, please correct that, it should be n. So students, what will the CF be? The CF will be yn. Actually, instead of yn, we will write an here, right? Because the solution we have obtained is in the form of an. To clarify, write an. So the CF that we will obtain is an. Here, we will once again obtain the CF to be an, right? What will this be? It will be an is equal to. So the solution we will obtain here, what will it be? It will be a1 plus a2n. Minus 2 power n. Now, what will we get? What will be the solution for this? So the solution will be this, and in this way, we will solve it. Now let's talk about the roots. How are they? So the roots are complex numbers and non-repeating. Then in that case, what we do here, we will take a question. So this will be an plus 2an minus 1 plus 4an minus 2 is equal to 0. Now let's assume this is a difference equation that we have and we will solve it. What will we normally do? This is x square, add x power n in the same method that I told you. So we will get 2x n plus 4 is equal to 0. We need to find its values, I mean roots. So what will be its roots? So x is equal to minus 2 plus, and this is b square, which is 4 minus 4 times ac. So it is 16. This gives us 16 divided by 2. We have this value as minus 2 plus minus, we will get minus 12. Okay. What will this be? So this will be 3, this will be 2. It will be root 3 iota divided by 2. When we simplify, what will we get? We will get minus 1 plus minus root 3. What will this be? We will have the roots here. Now, I want to tell you what we need to do here. So, the method of writing CF is we need R. Here, this is alpha. So, alpha is given to us as minus 1 and beta is given to us as root 3. We will find the value of R. It will be alpha square plus beta square. What will be this value? It will be 3 alpha square. So, 3 plus 1, right? So, we have 2 here. We have to calculate theta. So, students, what is theta? It is tan inverse beta by alpha, right? We have this formula. So when we solve it, it will be tan inverse minus, we have root 3 upon minus 1. So now in this, what will we get? We will get tan inverse. Now the value will be minus square root of 3. This value lies in the second quadrant. The value of pi is minus pi by 3, which simplifies to 2 pi by 3. We will take this value and put it here. So the answer we get will be an is equal to r. What is the value of r? The value of r is 2. Here it will be 2 to the power n, and from this it will be a1. What will this be? Cos n, 2 pi by 3, understood. Plus we have a2 here, and what will this be? This will be sine n 2 pi by 3. Pay attention. What will this be? Now, so CF will be like this. We are solving it in this way. So we'll discuss a question that is asked here, which is to solve the recurrence relation. Here it will be an is equal to xn. It will be like x square minus 3x plus 2, which I told is equal to 0 on solving. We obtain the roots 2 and 1. And it will be like this. So we have the CF. We can solve it in this manner. Now let's move on. How do we calculate the PI? PI is very important. These are the selected things that you need to remember. Here the function which we have will be in terms of n. In the exams, the questions typically involve either linear terms like n or n square, or involve sequences like an or nan. Now I want to tell you, if we have a function n of this type, right? So then its PI form is p1 n plus p2. Now let's take an example and I will explain through it. Suppose we are given an equation an plus. We have been given 4an minus 1 plus 4an minus 2 is equal to, here it's given as n plus 1. Now assume this is s. Since n is a function of n, so that's why it can also be n plus 1. It could also be 2n plus 1 or any other form. What we calculate first is its CF. I've already told about the CF. The auxiliary equation will be x square plus 4x plus 4 is equal to 0. We know that here the value of x will be minus 2 and minus 2. Now the CF that we will obtain, what will it be? So it can be written as an is equal to, this will become a1 plus a2n minus 2 power n, and this will be its CF. Further, we will discuss how to calculate its PI. The main point here is about the PI. When we are calculating the PI, then what will we have? The form of this PI. So whatever PI we have, it will satisfy this difference equation, right? So where do we put this P1 n plus P2? We put it in every term. Because the form of the PI, what will it be? It will be P1 n plus P2 type. We will consider it equal to an here. And after assuming an to be equal to this, we will put here, right? You know, whatever form we have for PI, this is a slightly special way to solve it. We have to remember this, right? So when the PI form is determined, we substitute it into the recurrence relation and then compare the terms. Okay, I'll put it here, and once I put it, I'll change it slightly. After I put it here, then it will be P1 n plus P2. Did you get it? So this will come as plus 4n minus 1. Then what will this be? It will be P1 n minus 1 plus this will be P2 plus here it is n minus 2. Then this will be 4pn minus 2. Okay. P1n minus 2 plus. What will come here? So it will be P2. And what will we do next? We will compare this with n plus 1. Now wherever we have P1 term, I will take it all together. We have one of the P1 term here. Let us now ignore the coefficient of n and focus on P1. Since it is not present, we will consider the coefficient of n here. Now one of the coefficient of n that we have is 4p1 and the coefficient of another n that we have is again 4p1. Is this right? This is the coefficient of n. We will discuss the constant. Where is it? So the constant is p2. We have this here minus 4p1, isn't it? Because when p1 will be multiplied by this, what will happen then? So this will be minus 4p1 plus, here we have this 4p2, right? Next here also this will be p1. When it is multiplied by minus 2, it will be minus 8. So it will be minus 8p1 and this we will have 4p2. Then this will be our constant term n plus 1. We know that this term is equal to its coefficient. Its coefficient is 1. So we have p1, 4p1. So this will be 9p1 equal to, it will be 1. So then what will be the value of p1? It will be 1 by 9. We will take this here. First we will see what is the value of p2, p2. So this is 1, this is 4 and this is 4. 4 and 4 is 8 and 1 is 9. So we have 9p2 here. And now what is 8 and 4? 12. This is minus 12p1 which is equal to, what will it be? It will be constant term. What is the value of p1? It is given as 1 by 9. So 9p2 and this will come out to be 12 by 9 which is equal to 1. Then 9p2 is equal to 1 plus 12 by 9. How do we solve? We will solve this as 9 plus 12 is equal to 21 by 9. So if we cancel, then this will be 7 and this will be 3. And now if we will divide 9, so P2 will be equal to 7 by 27, right? We will substitute the values of P1 and P2 into this equation. Then we will obtain the PI of this difference equation. So simply substitute the values of P1 and P2. So the value of P1 is 1 by 9. Now what will this be? Therefore, n into 1 by 9 plus, how much is it here? 7 by 27. After solving, what will we get? We will get PI. And in this way, we solve it. If we have a function of n square type, we have to put this value in place of n. Then we have to compare and find the values of P1, P2, P3. If the function we have is of the form a power n, then we need to apply this in such cases. Okay, let me show you another example. Let's say we have an plus, then what will we have here? So we will have 4an minus 1 plus 4an minus 2. Did you understand this? Is equal to, let's say this type we have, that is n3 to the power n, right? If we have data of this type, how do we calculate its PI? The form of PI we use is clear. I am referring specifically to PI, not CF, as it's already explained earlier. So students, now regarding the PI, we know that its form is, what is it equal to? It is equal to this, right? So we will take this equation as n equals to what will it be? It will be P1n plus P2 into 3 power n. Okay. The A we have here, we'll have to write it. We'll take this value and substitute it here. Then we'll compare it. Why do we compare? To obtain the values of P1 and P2. I am changing the color a little bit so that you can understand better. I have put this in. This will be P1n plus P2 into 3 to the power of n. Plus here this is n minus 1, 4. Now this will be P1n minus 1 plus P2 into what will this be? This will be 3 power n minus 1. Is it right? So let us move further. Okay. Plus this will come 4 and here we will put this value. P1n minus 2 plus P2 into 3 power n minus 2 is equal to, this will be n 3 power n. Right, students? Okay. Now please pay attention here. We will write P1n plus P2 and then what will we get? So we will get 3 power n, right? Plus here first, let's make it systematic. This will be P1n minus P1 plus P2. And this is 3 to the power n minus 1. Write it as 3 to the power n upon 3. Plus if we see this here, it will be 4. Then this will come to us as P1n minus 2P1 plus P2. Now in this, I will write this as 3 power n upon 9, right? Is equal to n 3 power n. Okay. So this is what we get. Now we will compare this with the term n 3 power n. So we will get this n 3 power n from here. Now I will extract n as a common factor and also 3 power n. Then it will be P1. Here also this is n 3 power n term. This will be 4 upon 3 P1 because this is 4 and this is 3, right? Next, we also have this term coming up, students. What will this term include? Then this term will include n as well. So we will have 4 upon 9 P1. Okay. We will handle the case where the coefficient of n is absent by writing it separately. So in this context, we have P2. Now, where the coefficient of n is not present, similarly where the coefficient of n is absent, then we'll have the term minus P1 upon 3 and plus 4P2 upon 3, right? Similarly for this term here, this 4 will go and this 9 will go. So this will be minus 8P1 upon 9. Now next we have 4P2 by 9. What will this term be? So this term will be A is equal to n 3 power n. Is this right? The coefficient of n 3 power n will be equal to the coefficient of this term. Since this is not present, it will be equal to 0. We will compare it accordingly. Let's determine the coefficient we have. I will change this color to red. It will be clear. Let's add this P1 terms, write it down. So 4 by 3 P1 plus 4 by 9 P1 is equal to 1. Is this clear? And what will this term be? This term which we will get, that is P2 minus 4 P1 by 3, right? Moving ahead. Plus 4 P2 by 3 minus 8 P1 by 9 plus 4 P2 by 9. What will the answer to this equation be? So it is equal to, we will get 0, right? Let's solve this. I will take the LCM of 9. So now this will be 9 and this will be 12 plus 4. And I will take P1 common in this way, okay? Is equal to 1. Now this value will be 12 and 4, that is 16 and plus 9, that is 25. So P1's value we have is going to be 9 by 25. Now listen, here we will solve this. We will again take the LCM of this as 9. What will happen when we take the LCM of 9? So 9P2 will come, minus 12P1 will come. Plus it will become 12P2 and minus 8P1 plus what will be here? So we will have this 4P2, isn't it? Is equal to 0. So 9 goes into 0. Now simplify this. How much is the value of P2, P2? It is 9 and 12, 21, 21 and 4. 21 and 4 is 25. So here the value will be 25 P2 and we will check the value of P1. So 12 and 8 it's becoming 20. So it is minus 20 P1 is equal to 0. And what will this be? It is 25 P2 is equal to 20 P1. And the value of P1, what we will get? 9 by 25. We will put this here. So 25 P2 is equal to 20 into 9 by 25. If we solve this, we get 5 and 4. So the value of P2 will be 9 into 4, 36. So 36 upon 25. So what will it be? It will be P2. Then the final PI will be in this form. Put in the values of P1 and P2. So the value of P1 is 9 by 25n, right? Let's move on. And the value of P2, what are we getting it as? So we are getting it as plus 36 upon 125 multiplied by what will it be? 3 power n. What will be the result? It will be its PI, and in this way we will solve this. So let's discuss next thing and let's try to understand the questions. Now pay attention. We have an equation here. How do we solve it? First we will find its CF. This will be m square or x square plus 5x plus 6. So 3 and 2 are the roots. You can easily find its CF in this. What will be the CF? Minus 2 and minus 3. So minus 2 and minus 3 will be its CF. Now we will talk about its PI. This PI is of which type? So the value of this is 42, 4 power n. That means it is a power n type. constant value doesn't matter. We are concerned with term n as we are calculating the pi of n term. This is in the form of 4 power n. So listen, this will be of this type. And its pi is pa power n. What will we do then? We will assume this as an. And what will be the an? It will be pan. P is there. Then what is a? It is 4. So we will take 4 power n, now the an. We need to pick this up and place it here. Then we will solve and compare it to get the answer. Let me demonstrate to you. So listen, now here we have a n, and what will the value of a n be? So it will be p4 power n. If you take this value and put it here, then what will happen? This will come to us as p4 power n plus. And what will this be? So this will be 5p. And 4 to the power n minus 1 will be there. What will be this value? It will be plus 6p and 4 to the power n minus 2. Right, this is equal to 42 4 power n. So what will we do here? We will divide this by 4. We will divide this by 16. So then by extracting the coefficient of 4 power n, what will we do? We will compare it with 42. After comparing, we will obtain the value of p from here. Okay. When we solve, its value is equal to this. We know it is equal. So it will be 42 4 power 9. So here we have the coefficient that will be equal to 42. So we have 21 by 8p is equal to 42. Further, we know that if we cancel this, it will become 2, right? And if we multiply this, what will be the value? 16 means the value of p is 16. 16.4 power n will be the pi. Now, how do we solve it? Next, we will talk about some questions like we have this. So you are being asked that what will be its pi? 3n square minus 2n plus 1. So this fn is equal to n square type. And n square type, we know its pi is pn square plus qn plus r. What will we take here? We will take this as an. We will take this an value and put it in these three places. As soon as you pick this value and place it here, we will get this an value. So now here, the an minus 1 term will be there. And this 6 multiple will be with n minus 2. And we will compare this with 3n square minus 2n plus 1. So here we have n square term. What will we do? We will write all of that together. We will write the n terms together and the constant terms together. Then what will we do? We will compare it. So when you solve it, this will be the n square term. This will be the n term. And what will this be? This will be the constant term. So this one we have is the n square term. 12p is equal to, we will get 3. So then minus 34p and minus 12q. What will be the value of this equation? The value will be equal to minus 2. And 29p minus 17q plus 12r, what will be the value of this? So the value of this will be equal to 1. Put the value of p to find q. Then put p and q to find r. Finally, use p, q and r to get your answer by putting them in these three places. Now, as we solve for the p, q and r, we will obtain their values. These values will be used to calculate the pi. This method allows us to solve it very easily. Next, we will discuss how to solve the recurrence relation. We have this 0. We just need to find CF. However, there is no need to find pi. How will we do this, students? Whenever such question is asked, then we have this degree where it is given as 4. We will write x to the power 4 here. It's important to remember this, right? So, then the next term that we will get here, what will it be? It will be x cube plus this will be 3x square minus 4x. And plus 2 is equal to 0. Here we will find the value of x. When we calculate the value of x, it is 1, 1 plus minus root 2 means it will be iota root 2. 1, 1 is a repeated root. So this CF extraction method is in this way. And when we have an imaginary root, we have this formula where the value, what will it be? So the value of r is the square root of alpha square plus beta square. So alpha is given to us as 0 and beta is given to us as root 2. We will solve this. So the value of gamma, the value of r will be root 2 only. Use this value. Since it is root 2, so it is 2 power 1 by 2. And since it's power n, it is 2 power n by 2. We need to find the angle. It is theta equals to tan inverse beta by alpha. Beta has been given as root 2. Alpha is given as 0. So this is infinite. The value of infinite will be pi by 2. So this will be the value of it. And in this way, we write the CF here. We will talk about the difference equation that we have been given, and we need to solve it here. First, we will calculate the CF. So how do we calculate it? We need to pay attention here. Now this is because here the difference is 1. Okay. What will this be? So this will be x plus 1 will be equal to 0, right? The highest degree will depend on the difference, right? So x will be equal to minus 1. And if it's minus 1, then it will be CF. Now students, we will talk about pi. So pi is 3n into 2 power n. This question, I solved it in the example. In a function, its pi will be in the form pn plus q to power n. A power n is involved and a is 2. It will be 2 power n. Now take this value and put it here. Then it will result in this. When put here, it is n minus 1. So Pn minus 1 q2 power n minus 1 will be here. We will solve it and compare it with that. We will proceed with this comparison. We know its value will be 3 and 2 power n. What will we do next with this? 3 and 2 to the power n. Now we will compare it. So now here we are getting 3n to the power n. Here we have 3n means n to the power n. When we talk about it, then it is n to the power n. So we have the coefficient for this one. What would be the value of this? It would be 3 by 2p is equal to 3. The value of p here is 2, right? So this will become the value of p. Now next, this coefficient we have 0. It means the next value is also 0. This will become equal to 0. Now this will be 3 by 2 q minus p by 2 is equal to 0. Put 2 value here, okay? It will be 3 by 2 q minus 1 is equal to 0. So now the value of q, this will be 2 by 3. Here this will come to us as p and this will come to us as q. What will be its value then? So it will be 2n plus 2 by 3. And into 2 power n, this is how we will get its pi. Therefore, in this way here we can solve it, right? Final answer of this is CF plus pi. So this is CF and this is pi. Then what will be the final answer? CF plus pi. So we solve it in this way. So thank you so much for watching me, and did you like it? Please comment and let me know. If you want to watch more videos on discrete mathematics and graph theory, check here. If you are preparing for any competitive exam, or you want to find out how to use short tricks or what short tricks are, you can see it here and check it. This is my new channel. You can subscribe to it by going here, and you can follow me on Instagram by going here. Thank you. Bye bye.